Today we will explore a concept of profound importance for our shared future. It is called a systems of systems perspective. This idea helps us see the intricate parts of our world not as isolated fragments, but as deeply linked networks. Each part, from the smallest farm to the largest city, operates on its own. Yet each also influences and is influenced by all the others. To plan for generations to come, we must think about many systems all at once. It reveals the hidden architecture of our planet, a tapestry woven from countless threads. First, a system is a collection of components that work together for a common purpose. These components can be people, plants, machines, pipes, or rules and traditions. What matters is that they are connected. Beat. Let us begin with the first of our 5 key systems, energy. This is the system that powers our homes, industries, and transport, the engine of modern society. We have long relied on fossil fuels like coal, oil, and natural gas. More recently, we harness wind, sun, and water. Each source has consequences. Fossil fuels warm our planet. The infrastructure is immense. Vast plants, sprawling grids, and pipelines crossing continents. It requires enormous investment, decades of planning, and skilled workers to operate and maintain. Policies shape whether we keep old methods or adopt cleaner technologies. Renewables are cleaner but need land, and for bioenergy, water. No source is without trade-offs. Humanity uses over 160,000 terawatt-hours per year, like everyone running more than 2,100-watt bulbs, continuously. That demand links energy to everything we do. Pumping water, harvesting food, illuminating our cities. Now we turn to the second system, water, essential for all known forms of life. Water systems capture, store, clean, and distribute this precious resource, a blend of the natural and the man-made. From great rivers and lakes to vast aquifers, reservoirs, pipes, pumps, and treatment plants. Clean, reliable water underpins public health and major industries. Globally, farming accounts for about 70% of freshwater withdrawals. Water links farms, power plants, and cities in continuous flows. Energy depends on water, cooling fossil and nuclear plants, hydropower flows, and even resource extraction. Producing energy requires water. Moving and treating water requires energy. Pollution raises treatment costs. Overpumped aquifers may take centuries to recharge. Wise water stewardship is an environmental, economic, and social necessity for farms, cities, and nature. Our third system is agriculture, the bedrock of civilization. It provides food, fiber, and many other products. It depends on healthy soil, a stable climate, reliable water, and energy to power machines, transport, and processing. For millennia, farms have shaped our landscapes and societies. Good practices prevent erosion, store carbon, and help mitigate climate change. Integrating trees and shrubs creates habitat and improves resilience to drought and heat. Overuse of chemicals can drive runoff that pollutes rivers and coasts, creating dead zones. Plowing fragile soils and converting forests and grasslands to monocultures erodes biodiversity and topsoil. The decline of pollinators threatens yields. Choices on farms directly impact ecosystem health. Agriculture occupies nearly 40% of ice-free land, employs the most people, and links to every other system. We now arrive at our fourth system, urban design. It governs streets and buildings, public parks, and transportation networks. For the first time, more than half of humanity lives in cities, centers of culture, commerce, and consumption. Cities draw vast quantities of energy, water, and food from near and far. Design choices shape resource use and resilience. Sprawl raises energy and land demands. Compact, walkable cities can reduce energy use and preserve land. Materials matter. Heat-absorbing surfaces drive urban heat islands. Parks, green roofs, and shade trees cool cities, manage stormwater, and support urban biodiversity. Treating and reusing wastewater turns waste into a resource. Cities are hubs of research, policy, and social change, critical nexuses linking energy, water, and food to daily life. Our fifth and final system is ecology, the foundation of life. Ecology studies relationships among organisms and environment across oceans, mountains, forests, wetlands, grasslands, and reefs. Ecosystems are active, working systems that provide essential services we often take for granted. Forests and oceans absorb enormous amounts of carbon dioxide, helping regulate climate. Wetlands act like sponges, soak up floods, filter pollutants, and deliver cleaner water downstream. Insects, birds, and bats pollinate a huge share of our crops, a service worth billions annually. Biodiversity yields new medicines and genetic resources for improving crops. Healthy watersheds secure water. Living soils and pollinators sustain agriculture. Coastal ecosystems protect infrastructure. When ecosystems are degraded, services are lost, often with severe consequences for people and economies. Preserving and restoring ecological integrity is an investment in our collective future. Having explored each system, we now focus on the weave of connections between them. These systems do not operate in isolation, they are intricately intertwined. The energy-water nexus. Generating electricity requires water. Treating and transporting water requires energy. In a large river basin, forests regulate flow, farmers irrigate, cities draw water, and power plants cool with river water. During severe drought, reduced flow stresses crops, city supplies, and power plant cooling, pressuring the whole system. Prioritizing one sector can trigger shortages or power cuts elsewhere. A narrow single-system approach is bound to fail. A systems of systems view asks, how can we use water efficiently across sectors? Can cities' treated wastewater irrigate crops? Can agricultural wastes fuel bioenergy instead of displacing food or nature? Interdependence creates significant risks and remarkable opportunities. A failure in one system can cascade. Heat waves strain grids, blackouts disable water pumps and hospitals, creating public health crises. Solving in one domain can harm another. A dam may generate clean power and irrigation, but block fish and starve deltas of sediment. A systems of systems approach makes trade-offs visible before we act. Integrated actions yield multiple gains. Planting street trees beautifies, cools streets, lowers energy use, reduces runoff, filters air, and supports biodiversity. Smart redundancies, microgrids and storage, and diversified food sources shift communities from fragility to robustness. By embracing interdependence intelligently, we build resilience across the whole system. A path forward. The systems of systems perspective helps navigate 21st century complexity. It urges us to look beyond energy, water, agriculture, urban, and ecological systems in isolation. It reveals cascading risks and hidden trade-offs, and illuminates solutions that are more resilient, efficient, and equitable. We must move from understanding connections to actively managing them for people and the planet. First, map regional systems. Identify key components and quantify flows of energy, water, and food to create a shared, factual basis. Second, initiate small pilots. Harvest rainwater for gardens, turn food waste into compost or energy, and learn by doing. Finally, share results widely. Build networks so solutions adapt across cities and basins, accelerating collective learning. This path is not simple, but it is hopeful, toward a future where human systems thrive in harmony with the natural world.